there's been a fair degree of consensus that we need perhaps more spectrum in the sub-gigahertz, to make this successful. There are some other issues and challenges that perhaps need to be addressed. When we look at RAP, DRP, what exactly is the uptime? How many utilities who are, implementing or have delivered most of the links? What is the uptime? Technology availability is not the challenge. How it has been deployed, what is the uptime? I think we need to dwell some more on that. What other distillation that perhaps should come out or is coming out is we need to define communications, with a high degree of granularity. I mean, it's not just we define by byline items, we need to define it by the home area network, the field or the neighborhood area network, the wide area network, and the core network. So how do we go about this? Do we have a separate section in the RFP for smart grids, or do we define communication links as a separate product, when we are defining smart meter or when we are defining electrical equipment? Do we also go ahead and define communication needs as a separate product, which is specific to geographies of each utilities and their needs? I mean, these are some of the questions. I mean, if anyone from the audience has any questions, great. Otherwise, Mane Saab, I mean, you're from the utility. I mean, what are the challenges that you face? I mean, what are the questions that you would like these technology providers to address? I mean, we have on the policy and the framework side, certain questions. Do we go ahead and define communication needs based on, say, a specific requirement of a utility? Do we define the communication needs based on, say, the home area network, the field, or the wide area network? How do we go about this? Because we all know that none of the utilities have a very significant uptime. We all know what went wrong, so it's important to go ahead and decide on how to make things right going forward. Help you with this. Yes. Yeah, here
you go. Yes. Challenge is what I will give my experience in this RAPDRP. Regarding the connectivity, I will start with the lease line itself. I will start from that. We are facing problems. I see I will not take the name of the service provider. In first meeting, we said that maximum you give on wired network, but I got 10% of it. So that is the first thing. Second thing is on latency. It should be below 75. It is above that. That is also another thing. On MPLS, forget about wireless. MPLS, I would say wireless, but it's a strong thing. Everybody says, but this is the problem we are facing on MPLS side. Now, this is second thing is this AMR, where we are gone for GPRS. I have got two technologies, CDMA and the GSM GPRS. There also we have same, the success rate is same. You take GPRS or CDMA, the focus I feel that of the service provider is on voice, not on the data. So that is another challenge. So at this point of time, I required to connect 74 metering points, but the success rate is now, as he has shown in this, 70%. So 30%, yes, I am not getting the data. I am not getting data in an area which is near to Mumbai, that is Vasai. So this is also, Rajani also knows that. So this is the real thing. This first thing is that technology is there, but actually that service provider, his focus is not there. So that is challenge in, say for example, you take Pune city or Mumbai city, but if you go in rural area, there the this connectivity is a problem.
It's very true. You know, in the rural areas, all operators, you know, get, for example, if the SRS says that use GSM or CDMA, and we all know in the rural areas, most of the operators get their ROI from voice. You know, there are not, you know, as we saw it in the last MSCDCL last mile connectivity, you know, most operators have not gone and installed, so to say, GPRS cards on each of their base station towers. So, I mean, coverage is an issue, yes. But the other point that I wanted to say was, even despite the coverage being there, you know, have we done the right selection of technology? You know, have we first looked at what are the needs? You know, what are the geographical needs? What's the topology on the ground? No, we haven't. You know, we have just gone blanket GSM oblique CDMA. You know, perhaps the local wireless could have been used. The very little option was perhaps given for that. And again, you know, from the business perspective or from the business processes point of view, it was never defined that what would be the latency requirements. You know, I mean, I know we talk on this day in, day out, and, you know, I've been one of the key drivers for saying, you know, why don't we look at the latency? Why don't we look at the quality of service? Why don't I give you a dashboard to tell you how many endpoints have the, you know, necessary uptime? These all need to be captured as part of policy going forward so that we don't face those same challenges. And you are currently ahead of the rest of the country. So we can just imagine what the rest of the country is facing. And then what we are staring at is, you know, yes, Ra, you want to say something? Pass through.
Thank you, Mr. Chairman. I'll introduce myself for some of the panelists who don't know me. I'm Rahul Tonkia, scholar, researcher in smart grids, telecom, and a bunch of spaces, advisor to the task force and forum. I'm also have been a professor at Carnegie Mellon and taught telecom as well, and was vice chair of the UN ICT task force on low-cost connectivity. So I have an energy hat and a telecom hat. What we've heard from Manisab is the technology hasn't delivered what it claims or should have or could have delivered. I'm going to ask a different question, which is, let's assume we get the SLAs right, we get the uptime, the latency, and everything that people are asking for. Let's remove all the jargon and steps saying that as a functionality, which was your point, what do we need for the business processes? I want to get 15-minute readings on an LT consumer, every single one. And I want to spend no more than a couple of rupees a month in OpEx. Not capital costs, because then we can discuss bill of materials, chips, and go down, you know, and that's a separate one-time cost. Let's remove the one-time and just look at operational costs. Is any architecture and solution proposed getting us there?
Let me, you know, add on to that rather than answer that question. Yes, there is, but again, for what topography or geographical region do you want it? For which utility do you want it? It's so bespoke. What I was trying to get at was there is no one hat that fits all. You have all of these technologies, but they are not universally applicable across every geographical region. You just can't say that, you know, I would go ahead perhaps and use local RF, not sub-gigahertz, maybe 2.4 as an example, in dense urban environments where you have a lot of line of sight issues. So, I mean, the point I was trying to get at, we need to have not just flexibility, but, sorry, go ahead, Rahul.
So then to answer or build on your question, is it the wrong debate? In the sense, if you followed a layered approach, like the internet is, then as an end user, I don't care whether you're using FSK or OFDM, because quite frankly, that's a second order question. It's a technical thing, and some chips can actually do multi-baseband, and you can run it how you want. So A, why do they care? And B, like you said, one size doesn't fit all. So even in the best case, which is a reasonably available, reasonably dense, but not too dense urban environment, you know, what are the best? We
need to look at the transport layer, the network layer, you know, the OSI model, and that's what I would like the larger country to look at. You know, unless we look at it from that perspective, we would perhaps never succeed. You know, each utility perhaps need to go and look at what would be their network layer, what would be, they have to follow the complete layered architecture and say, these are what we have on the field, these are what our business requirements are, and then perhaps frame a separate RFP as, for want of a better word, a product for their specific needs. What has caused this complacency is, the penetration of cellular telephony in the country. Everybody has cell phones and they work. So there's a sense of complacency that yes, communications is ubiquitous. Yes, it is. But these are machine to machine. These are the devices that stay in one place. Sometimes, if you take water and gas, the battery life has to be 20 years or more, something to that extent, and those devices stay in one place. Similar to the electrical grid, it's still dynamic. You could have local RF in a region and construction taking place, subsequently close to that or in the vicinity of that area. You could have water tankers parked in front of a substation entirely blocking out the signals. So, we have, what I'm trying to say is perhaps, or very truly, not enough study has been done to, we are trying to have a one size fit all, which will never work. And thirdly, the utility has never looked into communications as something that is not just central but imperative to the success of whatever, RAP, DRP or smart grid program that they do. And then perhaps drilling down, each utility needs to look at, based on their bespoke requirements, the network layer, the transport layer, and so on and so forth, and have that put into the specification. Standards aside, standards exist. A lot of work is being done in standards. That's where I'm coming from, and I would like a little more participation from my colleagues here.
Sorry, there's a switch. You can use this. Sure. Hey, I think I used that in one of my slides, saying that it's critical to start with a reference model first before we, start putting in use cases and things. If we don't know what network infrastructure we have today and what are the needs for tomorrow, and it's not only for one application, and it's for when we add multiple applications. What are the network requirements? What are the bandwidth requirements? What are the delay requirements? What we need today? What we will need in 10 years' time? So those are the reference model. A lot of utilities worldwide are doing it today globally. And CAPEX versus OPEX is always a discussion. I mean, a lot of utilities I've seen where they have gone with their own network. For example, a lot of utilities have their own fiber optic network to 66 kV medium voltage substations. And what now they're doing is, they're planning to extend the mesh from AMI to the nearby 66 kV substation, or when the new substation is built, they're already putting fiber network to the new substations, their own MPLS network. And again, MPLS is not, something that is guaranteed for low latency applications, just to answer that question, because MPLS is if it goes with one network, one hop, certain number of hops, you have 4 milliseconds, 10 milliseconds delay. But say next time, if it follows another route, you have another level of delays. What you need is definitely different set of products and requirements on the substations, which remove those kind of issues on latencies and this thing. I don't want to pitch on products, but at Cisco we do have products which you can guarantee on latency applications. But again, reference model is critical to start with.
Joy, I'd like to go back to our November workshop discussion. Somebody mentioned the point that if tens of millions of meters are connected and they are going to send the readings every 15 minutes, the basic telecom network switches are not designed to handle that kind of load. That's a much bigger problem. We have to, if it is so.
I made that statement, yes.
So basic telecom, backbone telecom network switches are to be redesigned for accommodating, say, 50 million meters, AMI meters. Then that work should start right now. So that's one part. And number two, do we have a consensus among the panelists that 865 to 867 is too small a slice and that is a weak spectrum? We should advocate with the government to release some other spectrum. So that's some other points.
Let me answer the second query first. Yes, absolutely there is. And in fact, Mr. Bhupinder and a few others, they would contribute to an approach paper, to perhaps represent to the MOP on the need for more spectrum on that. On the first question, rather than a lack of switches, what I actually said was, we don't have enough capacity on the wireless data VPN to have the parallel or concurrent sessions. I mean, if you look at the going forward scenario where we may have, assuming 25 to 30 or maybe 100 million smart meters, and most of them would definitely, Mr. Mane, correct me if I'm wrong, at 12 midnight end of the month, would need to be read for billing. Maybe not the DT meters, but the consumer meters certainly, yes, overall categories. And you would have perhaps a load on the network where you need to run, say, 30, 40, 50, 60 million concurrent data sessions. And I don't think any of the cellular operators per se are prepared for that. This is very different from the stress on the data, the network that they are facing because of the increasing number of smartphones. The number of concurrent sessions are not as much. But when you look at a utility where you have fixed devices latched on, to a base station tower, not changing, and all of them come alive at a given point in time, you need maybe millions of numbers of concurrent sessions. Yes, work has started on that, and what all the utilities need to understand, cellular operators need to understand and create is capacity on the wireless data VPN or wireless data public networks for this. So.
Can we have a team which will study what is the capacity of the backbone network, the switch, and in order to facilitate this kind of a, say, 50 million meters in 5 years or 100 million meters in 10 years, what is the augmentation to be done on the backbone network? Can we come out with some recommendation which, and see what kind of an income or revenue the telecom operators will get? How can we motivate them? What need to be done for that?
Right, so the data is already there. All the operators, collate the data with the regulator. So all of this data already exists in terms of capacity. More than the core network, it's the central processing capacity that they need on the wireless data VPN. And yes, I think we should do that. Yes.
See, it talked about 15-minute reading being collected. Just for the billing purpose of it, if you get all the 96 readings of a day at any point during the 24 hours, it's fine. Manasa problem today is solved if you get all the 96 readings in one go in some time during the 24-hour block. But the bigger problem is that suppose he has 50,000 DR customers, 50,000 customers who volunteered for the DR program, and if he has to reduce their load at the press of a button at 5 o'clock or 8 o'clock or whatever time of the day, that 50,000 fellows, we need instant connectivity. So what is the most reliable medium for demand response? One side we are articulating with the government that demand response, let us push for demand response for all the people with X kilowatt and above. So once it made it mandatory, and then what is the option available to have that objective achieved? Press of a button, we should get those, say, 100 megawatt load or 200 megawatt load reduced.
But most are not instant. Most demand response markets are sort of ahead.
No, but our problems are different. That's what we are telling. Peak load management can be done, so we'll, on a press of a button, we automatically will be able to reduce that. That's an incentive objective with which government may be coming out with any such DR mandatory programs. So,
right.
But what is the readiness from the telecom side? What are the most reliable communication medium for that?
So if I may just shift the debate to a little on the utility side. Yes, if you look at, there are a lot of, I did say that, you need to have bespoke requirements based on the topology and the geography of a utility. But when we look at the uptime and the connectivity, even from the utility side, if we keep telecom aside, most of the utilities, for example, don't have, robust or even mature enterprise systems. Yes, for example, Mr. Mane would agree, we have 70% data. 10% data doesn't come because what happens and changes on the field. For example, if there's a meter with a modem connected to it and the meter changes, there's no way for the central data center to know that the meter has changed. And, so they end up pulling the old meter which was there and they don't get the data. So these are the issues also that contribute to data. But to answer your question, there are so many, yes, it can be done. Cell phones are ubiquitous, cellular is one, but we cannot just again say that one hat fits all. You could have a utility in Northeast and it's very difficult for them to get 15-minute data on cellular. Or, the other point that I was trying to make is in the RFP, none of the utilities or in the SRS, they have defined the session. You know, if for demand response, the session is that I must have the data in 15 minutes, and for that, I must have a latency of 30 milliseconds. Then working backwards, the meter should respond back to me in less than 30 milliseconds. You know, so that when you poll the meter gives you the data. If the meter responds back to you in 2 seconds and you have a network latency of whatever, 150, 200, 350 milliseconds, that still wouldn't work. So the point that I'm coming at is it needs to be integrated. And here I think ISGF is playing a very significant role where each of the working groups are collaborating with the other working groups to make sure, you know, we have a kind of a married requirements. You can't have the metering requirements done in isolation and the communication requirements done in a second silo and, you know, expect the twain to meet. It'll never happen. And I wanted to put up that slide to say that, you know, going forward in smart grid, we need to break the problem statement into smaller bits and say, yes, this is the home area network, these are the choices, depending on topology, these are the recommendations, this is the field area network. I think, Sailesh, you mentioned about why are we using ZigBee for a field area, or you know, in the US perhaps it can't be, in India perhaps it can, you know, and the idea is not to put a block hole to that. So, and we need to granularly define what's the you know, field area network, what are the choices for wide area network, and hence, you know, that's obviously one of the purpose of this session, sir. Debate on that. Would you like to say something, Nitin?
Sure. So, yeah. So, like you mentioned, yes, there will be these millions of connections that will come alive at the same time. Now, some of the technologies that we are currently experimenting are about, can I have a complete block of the data from the meter aggregate into a single device and then send it across, and by doing that I can possibly reduce the number of concurrent sessions by 1 by X time and so on.
Already running away from that, what Mr. Reji asked about, okay.
So,
right.
Yeah, and secondly, like, yeah, you rightly pointed out, rather than having cellular do fit everything, can we look at the home area networks and the LANs and so on, and that may help us reduce the load on any one technology.
Right, thank you so much. I think this was a good starting point. I wouldn't say this was, you wanted to say something? Okay, we'll make it quick because we'll be holding people up.
I would like...
RAPDRP, we've not had much success. RAPDRP is just AMR, and in most states, it's just 50,000 odd devices trying to talk to the head end once in a day. And there too, we've all acknowledged that there's a latency problem and an uptime problem. Going forward with Internet of Things, where more and more devices are going to be wanting to talk to each other. See, in RAPDRP, AMR and AMI, it's still simpler. Somebody at the remote end wants to talk to one head end. They're not wanting to talk to each other. So this is a simpler problem than later, maybe 10 years down the line, when devices would want to talk to each other across. It would be a mesh. So going by RAPDRP experience, since uptime is not guaranteed, and even the latencies are posing a problem, do you think we are ready for AMI? This question is for the GPRS service providers, coming from an RAPDRP perspective.
Okay, first of all, let me interrupt you. Latency is not the problem in AMR. If you look at the Mumbai deployment, we polled 17,000 meters every 15 minutes with almost 100% success. And you know, I could perhaps connect my laptop and connect to the servers and show you that. So latency is not the problem. Again, you know, we are oversimplifying things by saying that, you know, RAPDRP, because you know, it has not worked because you know, we don't get 50% data or 70% data. Latency is just but perhaps one of the issues. And in rural areas, what Mr. Mane said, just to correct you, was he has more of a problem on the latency on the MPLS network rather than on the wireless network. You know, wireless networks, obviously the latency could go up as high as 350 milliseconds and still it would work. But yes, your concerns are very true. You know, and what we are trying to say is it's not just the communications that's been responsible, but it needs to be married on to the electrical device specifications, because I actually ran through my presentations. My key gist was that we have gone ahead and defined For example, RAP, DRP, everything at a very detailed level from a 500 feet level. Communications has been given just 2 byline items. How do you expect things to succeed with that kind of limitation? You know, I mean, that perhaps, a little colloquially answers the question. It requires a more technical answer to that, but I will end here because I think we're running short of time. Mr. Ebenson wanted to say something, and we could perhaps the last.
I would like to answer Mr. Mane's concern that the success rate is only 70% of uptime. I think this is basically because the RAPDRP came up with technology-based requirement for communication rather than a SLA-based requirement for the communication. What I learned from the banking industry is that from the technology they moved to a SLA-based of late, and now they are successful. Now they are getting that. So probably that should be one of the thought process when we formulate a requirement for the smart grid projects. No, I mean, technology needs to be open.
So SL is 100% there.
Okay.
First is SL is there, they don't bother for that. All service providers, I have 3 service providers with me. Don't bother them. Whatever I am getting, for that I am paying, they are happy with that.
Okay.
Sir, I am also one of the service providers and I have not been paid for 2 years.
Vodafone is also there, and even Tata is also there.
Thank you so much, panelists and the audience, for this very lively discussion. Can we have a small 5-minute break where we pick up our tea and come back into the hall and start our section 2 immediately?